Hi, my name is Claire, and this is the Butterfly Board, a tactile, assistive, and augmentative communication device for inclusive education because communication is a human right and every child deserves a functional communication system when they start school. But the project started really broadly with three key goals of educational equity, environmental responsibility, and an inclusive design practice. Intellectual disability is the most common disability type in Australia, and we're obligated to provide an inclusive education, but that's something that's really rarely achieved in Australia or around the world. Existing products are really limited to either extremely simple options or much more sophisticated and expensive tech, opening up this gap for a more affordable and more accessible product achieved through intuitive, interactive geometry rather than a flat screen or paper. This is how it works from a child's point of view. You can say, hey, I need to stop. The teacher replies, they say, do you need a break? Yes, I need to go to the toilet. Great, let's go. And then a reset switch puts everything back to neutral, indicating the end of that interaction. It can be used in the classroom, it can be used in a speech pathology clinic, and it can also be used at home. The lanyard ensures a child has access to their communication at all times and also allows a teacher to be modelling it constantly. The buttons are encased behind a cover plate, ensuring child safety and providing customizability, and also come as blanks, which means there's potential for tactile buttons for visually impaired children. The modularity means language development can be built over time, and this is essential because the Butterfly Board acts as a stepping stone entry-level device, giving access to more sophisticated AAC. So we're not trying to replace it, we're opening doors. But returning to the goals, the environmental responsibility is also essential, and the circular economy really shows us that recycling is the only accessible option for this, for people to engage with, which in Australia limits us to HDPE as a material. However, tristability is generally achieved using metals, which means we need to look into alternative methods such as compliant mechanisms. And this was validated through prototyping as being a feasible way to achieve this in real life, which is really cool. And it's integrated into the assembly here. You can see how the reset switch toggles the shuttle on the bistable component, and this is how the rest of the product is assembled. So all of this is out of HDPE, including the screws, which can be undone with a spoon if necessary. So no disassembly is required for recycling. On the costing, you can see that we can manufacture this for approximately $8 with up to 20,000 unit run. But if we increase that to 100,000 units, then it's down to $2 manufacturing cost. So this is really economically feasible. It's an economically feasible solution to a genuine problem. So to conclude, everyone deserves the dignity of having a voice. Imagine being 5 at school and having no way to say, I need to go to the bathroom. And this project is about designing for that. It's designing for equity, the environment, and inclusion. And all children deserve an inclusive education, which communication is really at the core of. Thank you, and particular thank you to everyone who provided expertise on this project and made it what it is.